Hi, this is Dr. Sridevi here. Welcomes you for the fifth topic, Transesterification reaction. It is the experiment for postgraduate level. Coming to the introduction, this experiment focuses on the synthesis of diesel fuel from vegetable oil. The mechanism involves a transesterification reaction, the process of transforming one type of ester into another type of ester. Here you can see a reaction between vegetable oil and also 3 moles of alcohol in the presence of a base. It gives glycerol and biodiesel. The main chemicals required for this green synthesis are vegetable oil, methanol, and sodium hydroxide. Coming to the clear procedure, the finely ground anhydrous sodium hydroxide was added into a pure methanol, which is taken in 250 ml Erlenmeyer flask and stirred vigorously until all the NaOH dissolved. Pure vegetable oil was warmed to 40 degrees centigrade and added into a beaker. The warmed up oil was poured into the methoxide solution with continuous stirring. At first, the mixture would become cloudy, but should soon into 2 layers will be separating out. This was stirred for 15 to 20 minutes. The contents of the flask were transferred into a separating funnel and the mixture will be separated into 2 layers. The glycerol will fall at the bottom and the methyl ester, that is nothing but biodiesel, will float at the top. Allow the experiment to sit for an hour. The stopcock of the separating funnel was opened and the glycerol was allowed to drain down into a small beaker and collect back the obtained biodiesel. In the transesterification of vegetable oils, a triglyceride reacts with alcohol in the presence of a strong acid or strong base, producing a mixture of fatty acids, alkyl esters, and glycerol. The overall process is a sequence of 3 consecutive reversible reactions in which di and monoglycerides are formed as intermediates. The stoichiometric reaction requires 1 mole of triglyceride and 3 moles of alcohol. However, an excess of alcohol is used to increase the yields of alkyl esters and to allow its phase separation from glycerol formed. Several other aspects, including the type of catalyst, alcohol vegetable oil molar ratio, temperature, purity of the reactants, mainly the water content, and free fatty acid content, have an influence on the course of transesterification reaction. Now let us see the mechanism of base catalyzed transesterification reaction. The first step, what you're seeing here, is the reaction of base with alcohol producing an alkoxide and a protonated catalyst. The nucleophilic attack of the alkoxide at the carbonyl group of the triglyceride generates a tetrahedral intermediate, which is shown in the equation 2, from which the alkyl ester and the corresponding anion of the diglyceride are formed, which is shown in equation 3. The latter deprotonates and the catalyst thus regenerating an active species, which you can see in equation 4, which is now able to react with second molecule of alcohol, starting another catalytic cycle. Diglycerides and monoglycerides are converted by the same mechanism to a mixture of alkyl esters and glycerol. The green context of our experiments includes that there are 3 green principles. First, the use of renewable feedstock, catalysis, and design for degradation. Vegetable oil is renewable starting material as it is derived from growing plants rather than irreplaceable materials like Earth's petroleum and natural gas supplies. The reaction is catalyzed by sodium hydroxide, making this process economically viable for the industrial scale production of biodiesel. Biodiesel is an excellent product as it is environmentally friendly. Safety precautions that to be taken during the synthesis of biodiesel. Methanol. Methanol is flammable and also poisonous. Dispose excess by allowing it to evaporate in fuming cupboard. Sodium hydroxide. It is very corrosive, cause severe burns and may cause permanent eye damage also. very harmful by ingestion. So here we come to the end of our topic, the transesterification reactions. Thank you for your patient listening.